All right, welcome back. So the first set of problems are to determine if a equation is separable. Okay, so are the following separable? This is number 2 in your textbook, and it's dy dx equals 4y squared minus 3y plus 1. Okay, so now this is just an equation. The right-hand side is just in one variable. So I could conceivably take dy over 4y squared minus 3y plus 1 equals dx. So I have all the y variables on one side, all the x variables on the other. So yes, this is separable. Okay. Number 4 was dy dx. Y equals y e to the x plus y over x squared plus 2. Okay, so I could write that as dy over dx equals y e to the y times e to the x over x squared plus 2. Okay, so dy over y e to the y equals e to the x over x squared plus 2 dx. Also separable. Okay, but what you see here is that this one's a lot harder to solve, right? I mean, both of these are actually pretty hard to solve, but this one I know I could at least, I know how to solve it. I don't want to solve it, but I know how to solve it. This one, well, I mean, a couple integrations by parts, but we're not being asked to do that. Now, you probably ask, well, okay, you've given us 2 examples that are separable. What about something that isn't? I could easily do that too. Let's take number 4 and change it just slightly. Okay, so we'll call it 4 prime. dy dx equals, what if I had even just y plus x e to the x plus y over x squared plus 2? Okay, now I can't do that split, right? Because of the, I can try. Let's see what we can do. This is what happens when I go off script. But it's not going to be, I can't really just put all of the y's on one side and all of the x's on one side. Okay, it's just not, I don't know how to, I can't do it. Okay, not with this multiplication. So this is not separable. Okay, well, we've done a couple of those. Let's solve some. Okay, so let's solve dx dt equals 3x t squared. This is number 8 in the book, by the way. Okay, so we can do this. This is pretty straightforward, I hope. Dx over 3x. You know what? I can play around with it to make my integral easier. Dx over x equals 3t squared dt. Now I can go ahead, I can integrate both sides. Natural log of x equals t cubed. And remember, I put my constant on the side of the independent variable. okay? And now, just like what we did before, we're going to take exponential of both sides. So x of t equals some constant e to the t third. And now I can give a name to this constant because x of 0, when t is 0, this is just going to be 1 here. E to the 0 is 1. So I'm going to say x of t is x0 e to the t cubed. Okay? In fact, let's do one real quick. This is maybe the most important differential equation in existence. dy dt equals kt. Okay? So this means, what's this? This is saying the rate of change of a quantity, not kt, sorry, ky. The rate of change of a quantity is proportional to the amount of quantity you have. Okay, this, you should expect something crazy or something not so crazy to happen here. Okay, dy over y equals kt, sorry, k dt. Integrating both sides, you're going to get natural log of y equals kt plus c. Taking the exponential of both sides equals, same argument we had before, y of 0 e to the kt. So this is the model for exponential growth. And now you can see why exponential growth is so important, because this assumption that something grows in proportion to how much of it you have, that's ubiquitous throughout all of math and science and actually any sort of field, right? That's a very common assumption, very reasonable to make, and we use it often. Okay. All right. Let's do one more. We've got space. Let's take this number 10. dy dx equals x over y squared square root of 1 plus x. Okay, I'm probably just doing this because I want to show off my integration skills. Okay, or my algebra skills, whichever one is used here. Okay, so we're going to go ahead and solve, put all the y's on one side, all the x's on the other. So we get y squared dy equals x over the square root of 1 plus x dx. Okay, integrating. Okay, so the left-hand side becomes y to the third over 3 equals this integral. Let's do this integral over off to the side. Okay, x over 1 plus x. Let's say u is 1 plus x. So we have integral of u minus 1 over square root of u du. U to the 1/2 minus u to the negative 1/2 du. That's going to be u to the 3/2 divided by 3/2 plus u to the 1/2 divided by 1/2 plus a constant. And u is 1 plus x. So I'm going to go ahead and write down over here 2/3 1 plus x to the 3/2 plus 2 1 plus x to the 1/2 plus a constant. Okay, so far okay, right? All right, now here we're going to have to be a little careful. Okay, so let's multiply everything by 3. So we get y to the third equals 2, 1 plus x to the 3/2 plus, let me just check something real quick. I had it wrong before. Okay, plus 6, 1 plus x to the 1/2 plus c. We're going to keep that c there. Okay, not multiplying it by 3 because multiplying a constant by 3 doesn't change the character, the way that it shows up, right? Still, you're adding it. But now when we take the cube root, we're going to keep the c inside of the cube root. Okay, we're going to keep the c inside of the cube root. All right, I'll talk to you guys a little bit more about that later.